What if I told you that Deathstroke's brain processes information 9 times faster than yours, and that real science might actually be getting us closer to creating someone just like him? Stick around, because by the end of this video, you'll know exactly how close we are to building a real-life super soldier. And trust me, the answer is going to blow your mind. Before we dive into the insane science behind Deathstroke's abilities, let's talk about who this guy actually is. Slade Wilson wasn't born a superhuman killing machine. He was just a regular soldier in the US Army who volunteered for an experimental program that would change his life forever. Back in the day, Slade was recruited for a top-secret military project designed to create the ultimate super soldier. The scientists injected him with an experimental serum that was supposed to enhance his physical and mental capabilities. But the serum didn't just make him stronger or faster, it fundamentally rewired his entire biological system. The transformation turned Slade into someone who could take on entire teams of superheroes single-handedly. We're talking about a guy who regularly goes head-to-head with Batman, the Teen Titans, and even members of the Justice League. But what makes Deathstroke truly terrifying isn't just his physical prowess. It's his tactical genius, combined with abilities that push the absolute limits of human biology. And here's the kicker. Unlike other comic book characters who got their powers from magic or alien technology, Deathstroke's abilities are rooted in enhanced human biology. That means, at least in theory, science could potentially create someone like him. The question is, how close are we really? Let's break down some of Deathstroke's most ridiculous comic book moments and see what the science actually says about them. First up, his brain. Writers have consistently portrayed Deathstroke as having a mind that operates at 9 times the efficiency of a normal human. Now, you've probably heard that old myth about humans only using 10% of their brain. That's complete nonsense. We actually use all of our brain, just not all at the same time. But Deathstroke's enhancements isn't about activating unused areas. It's about making the entire system work faster and more efficiently. We've seen him process multiple streams of information simultaneously, while predicting his opponent's moves several steps ahead. There's this incredible scene where he's fighting the entire Teen Titans team, and he's not just reacting to their attacks, he's anticipating them. He's calculating trajectories, predicting their tactics, and adapting his strategy in real time. It's like having a supercomputer for a brain. To put this in perspective, let's talk numbers. The average human reaction time is about 0.25 seconds. Elite athletes can get this down to around 0.15 seconds. Fighter pilots, who need to process information under extreme stress, can react in about 0.1 seconds. But Deathstroke? He's operating on a completely different level. He's shown dodging bullets after they've been fired, which would require reaction times measured in milliseconds. Now let's talk about his physical strength. We've seen Deathstroke punch through reinforced concrete walls, lift objects weighing several tons, and deliver strikes that can send armored opponents flying across rooms. The strongest humans on Earth, like strongman competitors, can deadlift around 1,100 pounds. That's incredibly impressive, but Deathstroke regularly displays strength that's at least 10 times greater than this. But here's where it gets really wild: his reflexes. There's a famous comic scene where Deathstroke briefly keeps pace with the Flash. Now, the Flash can move at light speed, so obviously Deathstroke can't actually match that. For a normal human, when you see something coming at you, your eyes send signals to your brain. Your brain processes the information and then sends instructions to your muscles. Nerve signals travel at about 120 meters per second in humans. For Deathstroke to react the way he does, his nerve conduction would need to be significantly faster, possibly enhanced through some kind of biological modification to his myelin sheaths. Then there's his healing factor. We've seen him recover from injuries that would kill or permanently disable a normal person. Gunshot wounds heal in hours, broken bones mend in days, and even severe trauma repairs itself with minimal scarring. In one storyline, He loses an eye and eventually regains his sight through accelerated cellular regeneration. But he still maintains the physical condition of someone in their prime. Deathstroke's body seems to have found a way to maintain peak performance indefinitely. Could real science actually create someone like Deathstroke? We're making some seriously impressive progress in several key areas. Let's start with brain enhancement. Scientists are already working on ways to boost cognitive performance through various methods. Transcranial stimulation, which uses electrical currents to stimulate specific brain regions, has shown promise in improving reaction times and decision-making speed. Some studies have demonstrated improvements of up to 20% in cognitive processing tasks. There's also fascinating research happening with neural implants. Companies like Neuralink are developing brain-computer interfaces that could potentially allow direct communication between the brain and external devices. While we're still in the early stages, imagine if these interfaces could be used to enhance natural brain processing rather than just connecting to computers. We could potentially see improvements in information processing speed and multitasking ability. Now, about those superhuman reflexes. Scientists have discovered that reaction time is largely limited by nerve conduction speed. Research in myelin enhancement has shown that it's possible to increase the speed at which electrical signals travel through nerves. Some experimental treatments have increased nerve conduction by up to 30% in animal studies. It's not 9 times faster, like Deathstroke, but it's a significant improvement. Muscle enhancement is another area where we're seeing real progress. CRISPR gene editing technology has been used to create mice with significantly increased muscle mass and strength. By blocking certain genes that limit muscle growth, researchers have created animals that are substantially stronger than their unmodified counterparts. The implications for human application are obvious, though the ethical and safety considerations are enormous. But perhaps the most exciting area of research is in regenerative medicine and anti-aging. Scientists have identified telomeres, the protective caps on your chromosomes, as a key factor in cellular aging. Every time a cell divides, these telomeres get shorter, and eventually, the cell can't divide anymore. But researchers have found ways to maintain telomere length in laboratory settings, effectively keeping cells young. There's also incredible work happening with stem cell therapy. These cells have the potential to become any type of tissue in the body, and we're already using them to repair damaged organs, rebuild muscle tissue, and even regrow entire sections of bone. While we can't yet achieve Deathstroke's instant healing, we're making progress towards significantly enhanced recovery rates. Gene therapy is another promising avenue. Scientists have identified specific genes that control muscle fiber composition, bone density, and even pain sensitivity. In theory, we could modify these genes to create individuals with enhanced physical capabilities. Some people are already born with genetic mutations that give them advantages, like the Sherpa people of the Himalayas, who have genetic adaptations that allow them to function at high altitudes where others would struggle. The challenge is combining all these enhancements into a single individual without creating serious side effects. In real biology, pushing one system to its limits often puts stress on others. Deathstroke's fictional serum somehow manages to enhance everything simultaneously while maintaining perfect balance. That level of biological optimization is still beyond our current capabilities. Current research into performance-enhancing drugs gives us some insight into the challenges. While we can boost individual aspects of human performance, steroids can increase muscle mass but damage the cardiovascular system. Stimulants can improve reaction time but cause long-term neurological problems. The military is actually investing heavily in human enhancement research. The U.S. Defense Advanced Research Projects Agency has programs focused on improving soldier performance through various means, from exoskeletons that augment strength to drugs that eliminate the need for sleep. While these technologies are impressive, they're still far from creating a real-life Deathstroke. The line between treatment and enhancement is becoming increasingly blurred. But let's be realistic here. While the science is advancing rapidly, we're still decades away from creating anyone who can match Deathstroke's abilities. The human body is incredibly complex, and enhancing one system often has unexpected effects on others. There's also the question of whether a human nervous system could actually handle processing information at 9 times normal speed without burning out. The brain consumes about 20% of our total energy, and dramatically increasing its processing power would require massive changes to our metabolism and cardiovascular system, even if we could create someone with Deathstroke's abilities. So what do you think? Are we heading toward a future where super soldiers like Deathstroke could actually exist? Which of his abilities would you want most? The enhanced brain power, the superhuman reflexes, or the accelerated healing? Let me know in the comments below, and make sure to subscribe, because we're just getting started with this series on the science behind comic book characters. If you enjoyed this deep dive into Deathstroke's abilities, you'll definitely want to check out our video on whether we could actually create Wolverine's adamantium skeleton. Trust me, the science behind that one is even crazier. Until next time, keep questioning what's possible.